Hey everyone! In this episode we are looking at how journey time information can be implemented as a journey time as a service offering, JTaaS for short, where instead of deploying extensive automatic number plate recognition, ANPR, or Bluetooth and Wi-Fi sensors across the network, this system uses data derived from connected cars which are driving on the roads which you want the real-time information for. I will be talking to David Montgomery from HERE and Dave Pregon from Yunex about how this is typically implemented. Anyway, I'm Alistair and this is at ITS Now. Journey time information is a useful data parameter for urban traffic control systems, UTC for short, to allow their operation to be optimized in real time to respond at a strategic level to different operating conditions across the road network. Although traffic management systems such as Scoot use vehicle detection technologies to automatically adjust the timings used at traffic signals, journey time data provides a useful confirmation about transit times of traffic through different sections of road, which could be through many individual sets of signals. This is referred to as a corridor. Journey time data is used by UTC systems to create a transit profile of traffic along a length of road. These sections of the road network are normally busy, such as arterial roads on the routes to and from city centres. The profile provides a useful comparison of current traffic flow to what normally happens at this time of day and day of week. This data can then be used to automatically adjust the operation of the UTC systems or to provide drivers with current journey time information, including via variable message signs located on the side of the road, allowing them to make informed decisions about their journey. The journey time as a service, JTaaS for short, that we are looking at uses data from the company called HERE, which is derived from information coming from connected vehicles on the road network. In this way, these vehicles provide what is often referred to as probe data. It is important to note, though, that any use of this information is anonymized so that it isn't possible to track the movements of specific vehicles. The HERE data is then used by Unix's Stratos system.
Hi, Alistair. Thank you for the invitation. Pleasure to be here on ITS Now. So my background, essentially, after studying electronics engineering in Australia many years ago now, I worked with several companies in the ITS space, initially around traffic and law enforcement. Moved on for there, working at Siemens for around 6 years, also spent a couple of years working in the UK. And now I'm based in Germany for a company that called HERE, as the logo says behind me, and we are revolving around how we can improve the industry from a data delivery perspective, less resources on the road, and that type of thing. So working now more in a software company and also more from a B2B perspective. So helping enable other enterprise customers to deliver then to the public sector.
So HERE, as a company, I just wonder if you could give our viewers a little bit of a background to that company, because I think a lot of people have seen sort of data on mapping backgrounds that HERE are responsible for, but I don't think a lot of the general public are aware of the sort of work that they're doing.
Yeah, no, for sure, happy to do that. And so the company itself, we're a global company. We have coverage in almost every country in the world. There are some exceptions, but certainly, especially the UK and Europe. We have a consortium of shareholders, typically automotive OEMs and tier ones. So just to name a few, apologies if I've missed some, but BMW, Daimler, Audi, Mitsubishi, Intel, Bosch. These are all part of our consortium of shareholders, and our main industry is actually automotive. And there we're delivering, for example, in Europe, around 80% of in-car navigation systems are using our map and navigation and a lot of content and even real-time traffic data inbuilt now in a lot of these vehicles. So this is our main industry, and this is why you might not see us so present at a lot of ITS trade fairs and things like that. So because our again, the second industry that we're active in is transport and logistics. If you think of Amazon, if you think a lot of these big transport and logistic companies were involved there, we're involved at the moment with companies like Uber and Lyft in deliveries of basically people organizing their Uber or their Lyft or ride sharing, ride hailing. Essentially, it all comes down to location intelligence. That's how we call it, and it's about identifying what is the key events for someone to improve how to get from A to B, or what is the optimal route, or what are the factors where data can support, for example, traffic and real-time traffic information.
Yeah, so obviously a hell of a lot going on there, and to be able to offer that as a facility that's going into a lot of end users across the transport network, all of these vehicles, then you need to have a lot of systems in the background to support all of that. So is that hence why what we're talking about today, Journey Time as a Service, would seem to be a very complementary service to that original offering, but to a different client group?
Yeah, I think so. It's been framed, or the data's structured in a slightly different way to kind of almost simulate existing or what I believe in the future legacy technology like Bluetooth or ANPR journey time systems. We offer a solution together with our partner Yunex Traffic that allows journey time to be measured through corridors, and we have over 200 already live in the UK as of today, without any infrastructure or hardware on the road. So aggregating that data from our automotive shareholders, combining that with other data sets that we have, even Spotify, for example. We're getting data from many different fleets and partners to which we can then aggregate all that together and provide an accurate journey time, essentially, without the need for people to go out on the road, shut down the road, install physical infrastructure, and that provides many benefits to cities and road authorities.
Yeah, because obviously traditionally we've always relied on having inductive loops and then other forms of vehicle detection spread out around the road network in order to provide us with basic traffic flow and density information, etc. And then, as you mentioned about ANPR and Bluetooth Wi-Fi, identification of devices in vehicles, looking at sort of OD information as well to get journey time information. But with the squeezes on many highway authorities on their financial situations. Obviously, that physical infrastructure costs a huge amount, and again, as you said about upkeep, maintenance, installation, all of those systems rely on a lot of people out on street, on the roads to keep them going. And so we're seeing a lot of movement, and with connected vehicles, ignoring automated autonomous vehicles for now, but connected vehicles are really providing a lot of opportunities to be able to step back from that physical infrastructure. So a lot of these vehicle OEMs that are integrating your capabilities on their navigation systems, presumably that is providing anonymized data back to you as well, so that you're getting probe data from those vehicles, as well as your aggregated data from other sources to input into this. I was interested, you mentioned Spotify, so how's that aspect working? That's not one I've heard of as a data source previously.
Yeah, no, sure. So I just one thing, don't get me wrong, that's certainly what I mean with ANPR, for example. It's still a great technology for specific use cases, for policing, for average speed enforcement. But in the case of a journey time, there's just more efficient ways to do it now. And certainly with a solution that requires no hardware, it's also flexible. And the way it's offered to our end customers is typically a price per corridor per year, meaning that, for example, if you have a marathon or a Rolling Stones concert or whatever, you're more flexible in how you use that data for one-off events. But no, Spotify, that's just an example of a data source where that we use to help calculate our speeds, our average traffic information. So all of these sources we combine together with data actually coming from the vehicles themselves, some of our shareholders, which I mentioned. We have certain algorithms and ways that we aggregate that. We do occasionally testing, ground truthing out on the streets compared to inductive loops and these technologies. But yeah, it's I find it too an interesting one, something that you might not think of straight away, but there's many different apps on your smartphone, and I don't think a lot of people actually read through all the terms and conditions.
No.
But at the end of the day, at least in Europe, you have the GDPR. So in terms of data privacy and stuff, that's one of the things we kind of stand behind, and we're very proud of how well we look after people's data, how secure it is. We put that at highest priority, and we have all the ISO accreditations and QA standards and everything like that to deliver on that.
Yeah, it's a few of sort of conversations I've had over the years. It's really surprising how attitudes in different territories around the world differ about user privacy. But yeah, it's always good to know that that is all covered off as well. So the corridors that you mentioned, so a local highway, a highway authority will engage with you to have a service where you're providing them with journey time information, presumably in real time, for particular routes, say in and out of a particular city, so the main arterial routes. Is that the sort of thing that we're looking at?
Yeah, the process we're integrated into the traffic management solution from Yunex Traffic. So they own the relationship with the road authorities, councils, etc. Because we provide access for Yunex to the data, which they then integrate into that
Okay, yeah.
end solution. Because you're updating variable message signs at the end of the day, so they're putting all the pieces together, and essentially our role is to provide a journey time for a specific corridor, which we provide to Yunex. Exactly, and that they provide the full traffic operator software for a city, and that's one key component of it.
Yeah, so you're adding more depth and capability to their urban traffic control systems. It's yeah. You know, I think we're seeing a big change through to these systems being operated as services rather than hardware installations. Good plug there with the mug as well.
It wasn't half deliberate.
So I think we've seen a lot of changes to these offerings to become services rather than hardware items. You know, when I started in this business, local authorities all had a server room full of racks of equipment with their urban traffic control systems, and now we're seeing many of those are now cloud-based, and therefore your capabilities are being ported into the Yunex system in order to provide more capabilities. So at the moment, that's providing journey time information, which will then be used within the UTC system to provide information to end users, like you say, via variable message signs and other capabilities that those systems will have. But do you see further capabilities in the next few years with this? You know, is it just going to be on particular routes, or do you think there'll be more depth and granularity, maybe across different road user types, maybe?
Yeah, there's a couple of things there. Thanks. It's a really good question. So one area I see is more weather and safety related data and information being available without the need for additional infrastructure. So a lot of these vehicles are becoming more sophisticated with more and more sensors as well, and you know, an Audi or BMW is able to detect that the road is slippery or icy or snowy. So so we're already collecting all this information also from the vehicle. So that's one area, kind of road surface, potholes, icy, snowy. This is data I think we can provide, but I see more of it being kind of acceptable in the ITS industry, because it's always, even with JTaaS, that it's a journey with the with the end customer. Like you said, nowadays cloud is becoming more and more acceptable. I remember a conversation 10 years ago with cities where that was like, I'm not paying for it if the server's not the hardware's not sitting, you know, in the room next to me, and I can.
Remember to hit subscribe for ITS now.
This is Stratos, and it's a UTMC system, and it's got lots of different modules in, and customers can take one or many modules of the system. So just to flick through them quite quickly, we've got a car park module here which I've preloaded, and in here you can see, for example, the status of the car parks. This is simulated data, so it's quite reoccurring, but we use this across the country for various authorities. And then it's going the different status of the car parks and the capacity and occupancy and so on, and then that's taken through to the signage in the system as well. That's the car parks module, which feeds into driver information module, and here I'm showing a data feed from National Highways, the endorse feed, and you can see the status of the signs on the network across there as well. So you can see journey time signs, or for example report of obstruction, and show that one on the map there and see the message. Environment module, we're taking in air quality data, we're taking in from our partner with EarthSense, so you can see various parameters there, PM, ozone, nitrogen dioxide, and so on. And we graph all that data, and the user can choose what they want to show on their graphs, and then we can take that all into the heart of the system, which is the strategy manager. We've got the driver information module we talked about. Disruptions is a live feed from National Highways endorse, but also from local data feeds as well. So from Street Manager, that's coming shortly. But for journey time as a service, this is something we developed in conjunction with HERE, and what it's doing is looking at floating vehicle data. And here's an example we've set up in Warwickshire near the arena. I'll just show that on the map. You see it's coming from the M6 down to the arena, and at the moment we profiled the data and you can see it's behaving normally, whereas last night, if I zoom in on that, you can see at 6:15 in the evening we were at 339% above normal, so something was clearly going off last night. So how do we create a new journey time link? So we just literally choose where we want to do it on the map, right click, add a link, say the fact that it's here, give it a name, Demos Highways UK. On the map we zoom in a little bit, start the link, move to where we want to end the link, hit end, using a routing algorithm to follow the road network. Created that, it tells us the length of the link, and we hit save. Created the link in there. You can see at the moment it's not valid because we've had no data yet. And what we do is we've now created that link. HERE know about it. It's number 865, and every minute we go and ask for the data, and then every 5 minutes we average that data to get the value that's then shown as this example here. There. So give that a few minutes and we'll get live data coming in. Obvious advantages, no one on street, quick to deploy, and we could move that to a different location if we're monitoring the scheme or something like that. So amazingly simple to use. We do that with currently about 15 local authorities across the country, from Edinburgh up in the north down to Plymouth right down in the south, so all over the country. And what we do then, we take all this data into Strategy Manager, and very, very easy to use. Literally drop, click, complex or as easy as you want for a strategy, and then we select the trigger that we want to go from one state to another, and then we can take any of these values in from all the different modules of the system as triggers. So for example, for environment, we take air quality or NO2 for example of a particular area and say, is it above, let's say 100, and we can create that as a trigger. We could take a link journey time in here as well. Let's look at one of those Warwickshire ones that have been predefined. Take one of those in the arena, and again we could say perhaps range below for low traffic flow, and let's say 50 seconds. And it's as simple as that, and then we can join them together with the logic value, and connect move it around, and change it from an all to an any, and that type of thing.
Thank you to David over in Germany and Dave, who I talked to at the NEC, for taking the time to explain how the collaboration between HERE and Yunex works. As more and more connected vehicles appear on the network, the requirements for a lot of roadside ITS infrastructure will start to diminish. This really is an example of how much of the traditional heavy ITS implementations will soon be obsolete. So a glimpse of the future. And lastly, could I please ask you to subscribe to our channel? It really does help us to bring you further videos about ITS. Thank you again to everyone who has subscribed. Thanks for watching. See you next time.